So thank you everybody for joining us today. If everyone could take a seat, we're going to start our program. And again, as I said, we're live broadcasting this, so as we do our meetup, just be sensitive to any conversations in the back because they'll be picked up on the video recording. So welcome tonight. This is our 14th Azure Gov meetup, so we're excited that you're here, and we're about 1,000 members of our user community. So
congratulations.
cool.
Yeah.
My name is Karina Hami. I'm one of the co-organizers and founders of the DC Azure Gov meetup, and then Vishwa.
Yeah, I'm Vishwas Lele, CTO for Applied Information Sciences, co-organizer with Karina for this group, and glad it's 14 months. That's been quite a journey. Yes,
and I am actually a part of Microsoft's Azure Government Product Engineering team based in DC. So really excited to see everyone here tonight. So we always like to start our program with why are we here tonight? And when we first, Vishwa and I started, talking about why do we want to meet user community and meet up, we really came up with these principles. And Vishwas, you always like talking about it.
Yeah, I like to talk about it because I think I've seen this community grow, and I wanted to point out some things. When we started this, I mentioned this last time. Some of you were here. That there were features that we were constantly clamoring about. That features that were not available in Azure Gov, features that were were available in Azure but not available in Azure Gov, and so we wanted to talk to the team, and Karina represents the Azure Gov engineering team, and there are other members of the team here as well, and we talked to them about the features that the agencies needed, we as partners needed, and we wanted to start a two-way dialogue of bringing together the features, the requests from the community back to the engineering team. So that has worked well, and I'm sure many of you who work with Azure Gov know that there's a rapid increase in release of features to the point that you can avail of most of the services in Azure Gov today. So that was one.
Every 32 hours.
Sorry?
New feature every 32 hours.
New features every 32 hours, right? And the other motivation has been, which has personally been a very, a great source of learning, not only for myself, I've been told by many of you as well, of bringing in not only the teams, but bringing in partners and agencies themselves. We have a number of agencies over the months who've come here and talked about the kinds of solutions that they have built, and to be able to learn about the solutions that they've built and be able to take those ideas back to our workplace and incorporate those. And then we encourage you to, as you embark on your journey, come back to us and be, volunteer to participate and present here. Even if it is a 15-minute case study of what you're doing, that'll be greatly appreciated.
Yeah, no, we've been able to showcase over 10 of our customer use cases and over about 12 of our partner use cases as well, so right. Scenarios. So that's been great. So if you have any, if you're working on innovation, this group is about you. And if you have any ideas of what you want us to present, please contact us via the Meetup website. And then our hashtag is #AzureGovMeetup. So also that's another vehicle to just communicate with the user community. Yep. And just with that, I just want to note for the 1776 folks that there's some music still going on that maybe we want to turn off. That would be great.
We usually enjoy the music, but
we
just
do,
not when we are speaking.
Yes,
demos, yes.
Right?
Just to be.
So just to kind of go over what we're talking about tonight, and this is really Azure and government services in general using advanced analytics. So with that, we have great presentations from Esri. We also have someone from the Microsoft team talking about how we're implementing analytics in government. And then a demo Vishwas is going to do wrapping up. We are also going to talk about our Hackfest that we're doing for developers and then Stephen McLaughty will talk about that towards the end, and that'll be exciting news for everyone here. So some key announcements, and this is what Vishwas was mentioning, is this is our opportunity to talk about, as we release something new every 32 hours, what is it? And also to hear from you, what are the features that you want to see, because this is really, for the product team, a way we can co-create the future together. So we got ATO High in VA and FERC, so that's big for us, and the data hub for Cloudera. And then the Azure Government Virtual Academy launch. So there's Azure Days that just launched, so we have a series of videos right now, if you look at Twitter, that you can also have an additional resource of finding out what's new in Azure. And then with that, upcoming events, there's always something going on with Microsoft, so we definitely want to make sure that you're aware of what's going on. And if you have any questions about it, we're always available, either in the networking session before or afterwards. Of course, any other ways of reaching to us, we'll answer with that. Did you have any words? I know you participate in Build all the time.
Yeah, fortunate enough to go to Build. Looking forward to that. And maybe, Karina, we can do a quick roundup. Anybody from here going? We could have a meetup at the Build. If not, we'll be happy to do a quick roundup from highlights of Build at our next meetup.
Awesome. You're on the hook then. With that, let's just go with our first presentation with Esri. Thank you so much.
Thank you. Do you need the second microphone?
No, thank you, Karina, and thank you very much for allowing us this opportunity to participate today at the meetup. Oh, thank you. Can you hear me? Yes? Okay. So my name is Lisa Connelly. I'm an account executive with Esri, and I'm on the national government team at Esri. And for those of you who may not be as familiar with Esri, Esri is a global geospatial software company founded in 1969. Over the years, we've developed into the worldwide leader of GIS, or Geospatial Information Systems. And in addition to our software, we offer educational and professional services as well. We also enjoy a long-standing partnership with Microsoft to include a lot of out-of-the-box integrations, such as Esri Maps for Office, SharePoint, Power BI, and we have our Cloud Builder in the Azure Cloud Marketplace, which allows our customers to easily and quickly spin up ArcGIS servers. But today, what we like to do is focus our attention on a specific use case or a customer, and that would be the Chesapeake Conservancy. The Chesapeake Conservancy is a nonprofit, a customer, thank you, a customer of Esri's, and they're a nonprofit organization. And their mission is to ensure a healthy watershed, which includes the fish, the wildlife, and the growing population. And part of that, a very important part, is to ensure that the runoff doesn't pollute the bay. So the actual bay is vast. It's over 200 miles long. But the Chesapeake watershed is even bigger. It starts in Virginia, goes through Pennsylvania, and goes as far as New York. So our customer, Chesapeake Conservancy, they built a model using advanced spatial analytics to run over this entire watershed. But they started facing issues when they were running these advanced analytics, this advanced analytic process over this entire area. Because you can imagine there was a lot of imagery involved, which requires an analysis on that imagery, which requires a lot of processing power and storage. So, and because that area was so vast and they were running this analysis over that area, you know, their machines were crashing. And this was at 30 meters of resolution. So not only were their machines crashing, they were also not getting the resolution they needed. So we recommended that they leverage the distributed processing power of the Azure cloud. And I'll turn it over to Bonnie, who will dive into more details about the processes.
Sure. Adjust this even further for me. All right, can you guys hear me all right? Good, all right. All right, so I just wanted to give a quick background on Esri's platform for those of you who are not familiar with it. Our technology spans, desktop, server, web, and mobile. But primarily we're seeing customers move the server technology as sort of the natural choice to start moving into the Azure environment. So that's really the foundation of our platform is getting users to web enable their geospatial data with a GIS server. So the list here is just types of GIS services that can now run in the Azure environment. So some of our users are taking vector data that create map image or feature services that are visualizations of that vector data. Raster data, which is important for this use case we're talking about today. From raster data, we can create image services that serve up those pixel values and allow you to do processing on them. Analysis services on your vector or raster data, so we call these geoprocessing services. These can be, you can see great benefit of leveraging the cloud to sort of spin up machines when you need to do heavy geoprocessing and then turn them off when it's no longer needed. Real-time data in the form of stream services that create pipelines to sensors and other networks to pull in real-time data and do visualization and analysis on that. And there's others that I won't go into today, but just a sampling of some of the types of services that users are creating with the technology. So I'm going to talk a little bit more about the raster services or the image services. So our image services, in addition to just managing and serving up massive amounts of imagery and elevation data is another use case, the capabilities of our image services provide rich analytical tools to process that raw imagery and create useful information products from that. And as Lisa mentioned, imagery can be quite large and require intensive processing. It just makes sense to distribute that processing across multiple instances within Azure. So some of the common analytical processes that people do on imagery include measurement, change detection, and feature extraction. So kind of translating imagery into actual features that you can then manipulate in other ways. So the example from Chesapeake, what they did was take some raw imagery data and then create a fairly complex model. You can see screenshot there in the bottom. Several raster functions chained together to process this information, create new information products from it, and ultimately derive a high-resolution land cover data set. That's ultimately what they wanted, was translating imagery into a land cover. So again, they saw great value in distributing this process over the cloud environment. It significantly reduced their processing time to map that entire watershed. You can see a screenshot here of the extent of the data that they process. So the boundary of the watershed is shown there. Obviously, they covered areas outside the watershed as well, just based on their source imagery. And so they ended up with a product, something like this, with a screenshot here with fairly high resolution detail. So we're going to look quickly at a video I had a colleague produce for us just to show for this demo. So I didn't have to show anything live. So here we're working within the Esri desktop environment, but we're connecting to web services running in the Azure cloud. So just zooming in and turning on whatever the original data that we have for land cover, which is the National Land Cover Data Set, which is a product created by sort of partnership between multiple federal agencies. And as you zoom in, you can see the coarseness of this data. So this is the 30-meter resolution data that Lisa referenced. So you can see at a local level, it's really not all that useful. So the goal was to create a much higher resolution version. This is the 1 meter product that the Conservancy. Oh, interesting. Let's see. I bet this is because you've got this extended. Thanks for pointing that out. Sorry, I'll go back here. So I'm just queuing it up to the part where you can see this is the 30-meter resolution data. as you zoom in, you'll see how pixelated it gets when they get down to a local level. So as the Conservancy is trying to partner with local governments and nonprofits to kind of direct resources for watershed improvement, that data just wasn't good enough. So now we're looking at the 1 meter resolution data that they created as part of their final product. And you can see much finer detail. You can see individual homes, driveways, trees, et cetera. And as we'll zoom back out on this map, you'll see, just how much data this was. It didn't just run it for this little area here in this demo. As we zoom out, it covers the entire extent of the watershed. Over 100,000 square miles is what they quote as the extent of the data that they processed. And I believe they got to about 90% accuracy with this model that they had created to do this classification and create this land cover. It covers 206 counties as well. Oops. What happened? Go back. Managed to close the video. There we go. All right. Yeah. So it should continue to zoom back out. And we'll get to a point where we can see some of the steps that they took in processing this data. Basically taking original imagery from the NAEP program, the National Agricultural Imagery Program that's run from USDA. They provide free imagery across the country. And then it's pretty generic 4-band imagery, so it's not terribly robust. But what the Conservancy did was translate that original imagery into some new derived products, some new band combinations to help them create their land cover. So over on the right, we're showing examples of some of the raster functions that you can apply to imagery. So raster functions are basically different ways to manipulate image pixels and create new products from that, apply some processing to it, render it in different ways. So we can use these functions to create new band combinations of the NAEP imagery. So we can look at things, they created a vegetation index, brightness, and something called chromaticity, which is a measure of the quality of the color. So with these 3 derived bands that we're showing here, they were sort of combined into a new false color image, which will be this purple and green one we'll see here in just a second. And that is really the core piece of information that the software needs to start delineating different features. We want to extract out, what are trees, what are water, what are impervious surfaces. So with this combined false color image, this is where the software will start to segment the different, pieces of the image. So one of the important things that it helps it do is distinguish things like roads that fall within shadows of trees. So being able to understand and figure out, is it a part of the tree, or is it actually a road in shadow? So now we're applying another function that's drawing those actual segments. So there's little black lines kind of outlining the features that the software has detected. So then the next step after that, after you've got these kind of isolated pieces of the image, we need to tell the software what each of those pieces represent. So we need to say, this pixel value represents water, this pixel value represents impervious surface, this pixel value represents vegetation or trees. So they can come up with training areas to tell the software this is what you look for, and then apply that processing to the entire rest of the image set across the entire extent of the watershed. So that's the kind of final product that you're seeing here with their initial 5 classes of imagery. So we're seeing that applied now, that renderer being applied to whatever extent of the imagery that they look at. And I'm just pausing it here to show the example of the model that they put together. This is just kind of one piece of it. But this is, within our interface, how you can chain those analysis processes together. And then that model can be served up as a service within Azure to allow, anyone to apply it to input imagery, right? So anyone can feed new information to it and get their own result. All right, I think I want to get back to the slides. I can pull the mouse back over here. Cool. All right. So For this project, they leveraged a couple different Azure services. Obviously, they were using virtual machines. So it was about 11 virtual machines with 20 cores per machine to support all this processing. And they stored that source imagery in the blob storage available within Azure. So as we mentioned, the geoprocessing service analyzed 100,000 square miles of data at that 1 meter resolution. And this represented about 900 times the amount of the original data in the 30 meter national land cover data set. So quite a big difference. So I'm going to turn it back over to Lisa to wrap up and talk about the success for this customer.
And then we'll have time for questions. But to summarize the successes, and to summarize the success and also the value that they gained from moving their analysis or their advanced spatial analysis to the Azure cloud, is that they significantly reduced the time needed to map the entire watershed area. And that was an example of that is that the 3.8 billion pixels were processed in 5 minutes as opposed to a week if done locally. And then this success enabled them to spend more time running additional analyses, like preventing the pollution runoff that I mentioned. And then another benefit, among others, is that these data sets can then be shared out as services to other state and local government and nonprofits that they work with and collaborate with in support of their mission. So that's really it. So if you have any questions. Nope. All right.
You talk about the 11 virtual machines. Is there any database servers that you use? And what are the Azure services you use?
So excuse me, I wasn't on the project, so I can't speak to all those details, but I do know, again, the source imagery was coming from blob storage. I don't know if they wrote out any new derived data, if that went in, probably not into a database. It was probably also written out into blob storage would be my guess, but I don't know for sure. I'd have to ask with the people that actually worked on the project. So just filling in for tonight.
Anything else? All right. Thank you.
Thank you.
Yep.